So hello everyone. In this lecture, we will see the one previous year question of 2022 question of GATE Aerospace, and this question was from your gas dynamic part. Okay, and they have asked for 2 marks in your aerospace. Okay, so we will try to understand the question, then we will try to understand the concept, what concept we will get from here, and we will try to use one equation in that, and why we are using, I will try to explain that. Okay, so let's go for this question. So this kind of question we have already done in the previous lecture using some equations of your nozzle, and we have already seen the questions of your diffuser or nozzle or any shape of duct. Okay, so this kind of question they have already asked in 2022. In the previous year they have also asked, and in the upcoming year they will definitely ask this kind of question of your duct. Okay, so let's see the question first. So in a converging duct, area and velocity at section P are, so this is section P, and 1 meter square and 15 meter per second respectively. The temperature of the fluid is 300 Kelvin. Okay, now airflow through the convergent airflow through the nozzle can be assumed to be inviscid and isothermal. Inviscid means they are saying do not consider the friction, your energy will remain same. They are saying do not consider friction. Okay, now and isothermal means you are, your temperature is isothermal process is known as when temperature remains constant, right? So in that they are saying temperature is constant from your station number P to station number Q. Okay, this is also P and Q. Okay, so the characteristic gas constant they have given 287, and the ratio of specific heat is 1.4 for air. Okay, now the condition they have given to ensure that the air flow remains incompressible in the duct. They are saying flow should be remains incompressible while it is flowing inside the duct. Okay, so the minimum area required at Q is in meter square rounded up to 2 decimal place. Okay, now okay, let's understand what they are asking first, then we will try to understand in our way. Okay, they have given the simple conversion nozzle. I hope you know this is the conversion shape of nozzle, and they have given the station number P and they have given the station number Q. Now they have given the velocity at the station number 1, station number P, which is your 15 meter per second. Now, right, 15 meter per second is entering inside it, and they have given the area at the P, which is 1 meter square. Then they have given the temperature, and they have said that temperature is remain constant throughout your duct, which is 300 Kelvin, right? They have given the isothermal, this is process is isothermal in the duct, right? Now they have given more data of your gas 280, for air 287, and gamma they have given 1.4, right? Now they are saying that when flow is flowing inside the, when air is going inside the duct, they are saying your Mach number should not go beyond that, beyond 0.3. That means your flow should not go in the regime of subsonic. They are saying that flow should be incompressible. That means your Mach number should be lesser than 0.3. In the question they have already given that your Mach number should be 0. Lesser than 0.3. Okay, or equals to 0.3. They have given these equals to. Okay, also be careful. So they are saying the minimum area required at the P so that your flow will remain incompressible. Okay, and they have said rounded off to 2 decimal place. Now if you see, this is a very simple question, just a piece of cake. If you know the continuity equation in this case, if you know the continuity equation, we have already done the question on the continuity equation, which is, now if you know, if you see, this is density, this is the area, and this is the velocity, and this is the again density, area, velocity respective of your station numbers. So one station number is entering entry station number and 2 is exit station number. Okay, I'm not writing P and Q. So if you see, they are saying your flow should be incompressible. That means your flow should be lesser than 0.3 Mach number. And one more thing, when flow is incompressible, that means change in density across the flow is zero, right? Change in density is very negligible in the incompressible flow. So what we do, we assume that it is negligible, this is not significant much change in density, so we neglect it. So if you neglect density in this case, or density remains same, so what will happen, density will cancel out from both the side, right? So I am neglecting the density because of the question they have given. Now my equation becomes this. Now this becomes your equation, right? Because we have neglected density. Now you have each and every data they have given. So if you see, area they have given, which is 1 meter square, velocity they have given at the entry, which is 50 meter per second, right? Area we need to find out, and we know now we don't know the velocity, right? Now if you know the Mach number formula, Mach number is given by velocity divided by speed of sound, right? And this is the shade number for 2, which is Q, so I'm adding it as a 2. Okay, now from velocity you can write it as a Mach number into gamma r t2. So I'm directly writing this velocity here, because why am I doing in this way, because I know for the continuity equation I know area, I know velocity, and for this velocity I know Mach number and I know temperature. So this is the back calculation method. You need to calculate, you need to assume that you need to predict what formula I have to use depending on the given data. So in this way you can calculate easily, otherwise you will calculate random data for that. Okay, so try to use this concept, back calculation method. Okay, so velocity I'm writing in terms of Mach number into speed of sound, right? Now you know, you just need to solve for area too. Just do this, right? Mach number is 0.3 because they have given lesser than and equals to, right? So equals to we are assuming in this case. We don't have any other option apart from assuming 0.3. Now you know gamma they have given already 1.4, 287 gas constant they have given, and they have given temperature. Why am I using T2 as a 300? Because at the entry they have given 300 and they have said the flow and the process is isothermal. That means isothermal means that T2 will be also equals to T3. That's why I'm using 300. This is basic thermodynamics. Now if you solve for these, it will be 104.15. If you divide this, you will get this as 0.114 meter square, right? If you round out to the 2 decimal place, you will get this as a 0.15, or you can write meter square, or you can write 0.14 also for 2 decimal place, right? So this become your answer. So you can expect and you can assume how much simpler question they have given. If you know the okay, let me tell you now. Yeah, if you know the continuity equation, if you know what does it mean by incompressible, when what does it mean by density is neglected, or density is not going to change, if you know all this thing, you can easily solve for continuity equation, and you can get 2 marks in your exam. This is just 0.30 second question. Okay, I have done lengthy because I have tried to I need to explain you. That's why I have tried to uh, uh, that's why I try to go in step by step so that you can understand. Okay, so for example, in an exam you need to do in a 0.3 0.30 second. Oh sorry, this is 30 second. Okay, you need to do in 30 seconds. So if you do this, you can get 2 marks in your exam, and this kind of question they have already asked. So this is your previous year question, 2022 question asked by IT Kharagpur, right? Okay, if you have any doubt, any query regarding this question or regarding aerospace, you can ask me in a comment section. I will try to answer there. Okay, let's meet in a next lecture. Thank you.